Galileo, for those who know your name but not the man, how would you describe yourself and the path that led you to challenge the universe as it was understood in your time?
It is an honor. History has called me the father of modern science, a central figure in a revolution of thought. But my path was not inevitable. I began my studies in Pisa, though I left without completing the degree. My early posts, first in Pisa, then in Padua, were practical positions.
You had to prove your worth.
Precisely. I designed useful instruments, such as the military compass. These showed the tangible value of geometry and mechanics. But for true research, work at the highest level, one needs strong and stable support. My move to Florence was a strategic decision meant to secure the patronage of the Medici family.
And you did that brilliantly. You dedicated your most spectacular discoveries to the Grand Duke in order to secure the title of philosopher.
Yes. When my improved telescope revealed 4 new satellites orbiting Jupiter, I knew exactly what I had to do. I named them the Medicean stars in my publication, Sidereus Nuncius, the Starry Messenger. It was a political reality. The move carried me from the competitive world of Venice into the protection and financial security of the Grand Duke. One trades 4 moons, you see, for a lifetime of freedom to work.
That may be the greatest bargain in the history of science. With that security, you were able to focus on your central philosophy. You insisted that mathematics is the language of the cosmos. In an era still dominated by ancient texts, why place numbers and geometry at the center of everything?
Because the universe is not an abstract idea to be debated. It is a physical reality to be observed and measured. My conviction, which I hold unshakably, is that nature, this grand book continually open to our gaze, is written in the language of mathematics.
So the blueprint of existence is geometrical.
Exactly. Its characters are not obscure philosophical notions drawn from ancient authority. They are triangles, circles, and other geometrical figures. Without this language, one wanders in a dark labyrinth. My entire method was a challenge to those who built their philosophies by memorizing principles without ever proving them.
If you can't measure it, you don't understand it. This brings us to your method, the primacy of experience. You famously argued that observation should outweigh authority. Why such faith in the senses?
Because sensory experience is the final judge of physical truth. Nature and Scripture both come from the same divine will, and therefore cannot truly contradict one another. But nature is rigid and unbending. If experience or necessary demonstration shows us a physical truth, that truth must be accepted.
So, in a sense, you believed we simply had better data than the ancients.
In a way, yes. Aristotle reasoned from what was perceptible to him, but we now possess instruments that bring the heavens 30 or 40 times closer. To prefer ancient conclusions based on poor senses over direct observation, that is not philosophy, that is stubbornness.
The instrument that made this possible was the telescope. When you first turned it toward the moon, what did you see that shattered the idea of celestial perfection?
The moon was the first casualty of that doctrine. Accepted physics demanded that celestial bodies be perfect, smooth spheres. But my telescope revealed a rough, uneven surface, mountains, valleys, shifting shadows. It was astonishingly similar to our own changing Earth.
You erased the boundary between heaven and earth simply by looking.
That boundary was always artificial. And beyond the moon, the 4 satellites of Jupiter proved that not everything orbited the Earth. There were other centers of motion in the heavens. These observations dissolved the old world, not through theory, but through visible, undeniable proof.
After the moon, you turned to the sun. In your letters on sunspots, you described blemishes on what was believed to be the most perfect body in the sky. What did they reveal?
They revealed change. Sunspots appeared, altered their shape, and dissolved on the sun's surface. Some were vast beyond comprehension, larger than entire continents. This contradicted the belief that the heavens were incorruptible. Alteration exists even in the most noble body in the sky.
You went further and argued that change itself is a form of perfection.
Yes. What is preferable? An unchanging lump of jasper, or a living creature capable of growth and decay? Generation and corruption are not flaws, they are the engines of life. Without them, nothing truly living could exist.
Let's turn to the great conflict, the trial over Earth's motion. In Dialogue Concerning the Two Chief World Systems, you proposed a physical proof for a moving Earth based on ocean tides. Can you explain your reasoning?
I argued that the tides were a mechanical consequence of the Earth's combined motions, its daily rotation and annual revolution. The waters were disturbed by these motions, sloshing in their basins. This provided a unified mechanical explanation for a moving Earth.
We now know the moon's gravity plays the primary role, something Kepler suggested. Why did you resist that idea?
I sought causes that were demonstrable and measurable. The idea of distant celestial influence felt occult to me, a relic of older philosophy. I wished to show that Earth's motion alone could account for the phenomenon.
The conflict ultimately became theological. In your letter to the Grand Duchess Christina, you addressed Scripture directly.
Truth cannot contradict truth. Scripture often speaks in ways suited to common understanding. It gives God hands and feet. It is not a textbook of physics. Therefore, demonstrated physical truths should not be rejected on the basis of scriptural interpretation.
Scripture teaches how to go to heaven, not how the heavens go.
Precisely.
Despite this, you were condemned in 1633. Can you describe that moment?
I was found vehemently suspect of heresy. I was required to renounce the belief that the earth moves and the sun stands at the center. I signed the abjuration with my own hand on June 22, 1633.
A profound moment in the history of science. Galileo, thank you for sharing these reflections. As we close, let's consider what this means for us today. Galileo's story reminds us of the power of observation, of trusting what we can see, measure, and test, even when it disrupts centuries of certainty. It also reminds us of the cost. So we leave our listeners with this question. What does it mean to pursue finite, demonstrable truths while remaining humble before the vast mystery that still surrounds them? Thank you for joining us on Beyond Time Conversations.